Today we'll be covering Chapter 2 in the textbook on studying behavior scientifically. In the very early history of psychology, so even before it became its own field, a lot of philosophers relied on the concept of rationalism to explain the ways of the world. Rationalism is the idea that knowledge can be obtained through reasoning, so essentially just by thinking about that topic. However, as psychology came into its own, it was argued that reason alone isn't sufficient. This is best exemplified through a short video, so please take a moment to watch the YouTube video at the link below before coming back to the lecture. So if we were to think about some of these situations using rationalism, you may logically reason that you would notice something as obvious as the person you were talking to being replaced by a new person entirely. But as we've seen, the phenomena of change blindness tells us otherwise. A surprising 50% or more of participants fail to notice this theoretically obvious swap. So we know that reasoning alone cannot be the sole way that we obtain knowledge about the world. So we rely on empiricism, which is the foundation of scientifically studying behavior, and is the idea that knowledge can be obtained through observation and experience. Most psychologists assume that behavior is governed by discernible laws or principles that simply need to be uncovered. The goals of the scientific enterprise of psychology are to measure and describe a phenomena, for example, motivation. To understand and predict, so to satisfy this goal, psychologists form hypotheses about how variables interact. A hypothesis being a tentative statement about the relationship between two or more variables, with variables being the things that are observed or controlled in a study. And lastly, to apply and control. So information gathered by scientists may be of some practical value in helping to solve problems in things like schools or businesses or mental health centers and so on. The scientific method generally functions by identifying a problem, gathering information related to the problem in order to be able to generate a hypothesis. Then an experiment is designed and conducted. The data gets analyzed and conclusions are drawn from those results. And then depending on what is found, this information can be put to use in an applicable way, and or more likely, it will be used to reformulate the hypothesis to answer a more specific question or to better answer that original problem. Some common terminology used throughout the course and in the research world in general. A variable can refer to any characteristic that can vary. So knowing which variables are of interest, which are being controlled, and which are being manipulated is very important depending on the type of research underway. Since variables can be defined in many different ways, take for example, motivation, this can mean different things to different people. Therefore, psychologists use operational definitions to clarify what their variables mean. So for example, what exactly is motivation in this particular study? Researchers use procedures for making empirical observations and measurements of their interested population, often referred to as the participants or subjects of the study. Methods can include direct observation, questionnaires, interviews, psychological tests, physiological recordings, and examination of archival records. Finally, they depend on statistics to analyze data and decide whether or not their hypotheses were supported. Observations are converted into numbers, which are then compared. And these results are typically shared through reports at scientific meetings and in scientific journals. This way, others can evaluate new research findings and build new ideas on top of the new information recently shared. Using the scientific approach, scientists state exactly what they are talking about, resulting in clarity of communication. The scientific method also yields more accurate and dependable information than, for example, speculation. One last thing to note is that there is no one way to approach answering a particular question. Research methods consist of differing approaches to the observation, measurement, manipulation, and control of variables in empirical studies. We'll go through a few key data collection techniques in psychology research, starting first with direct observation. Simply observing and recording behavior while being as objective as possible can be a great way to gather important information. Questionnaires are another great source, consisting of written questions designed to get information about a specific topic. I'm sure you've all participated in at least one survey thus far. Another common technique is an interview, where researchers engage in face-to-face dialogue with the participant and ask questions about a particular topic of interest. Psychological tests are quite common in experimental psychology, and these are standardized measures used to obtain a sample of subjects' behavior. For example, intelligence tests, which we'll talk about in a few weeks here. Physiological or neural recordings are also commonly used. These are instruments that monitor and record specific physiological processes in a subject. So some commonly used technology include EEG and fMRI. Finally, an often overlooked but important technique is the examination of archival records. So to analyze already collected institutional records, this is common and important work when investigating uncommon processes or disorders, or even to look at historical records using a more modern perspective or classification. Moving on now to the types of research studies. Descriptive methods consist of the observation of behavior without manipulating or controlling variables. Behavior, you can see, is in all likelihood your subject's true behavior produced under real-world conditions, so without the influence of an artificial setting. Additionally, as the researcher, you have no control over your subject's behaviors. There are a few types of descriptive methods. Naturalistic observation is when a researcher engages in careful observation of a behavior without intervening directly with the subjects. For example, you could collect data to answer the question of whether more men than women run yellow lights. Participant observation includes becoming a member of the group or gaining permission to observe a group in order to learn. A case study is an in-depth investigation of an individual subject. So, for example, as Netflix has demonstrated a demand for a profile of a serial killer, for example. And lastly, in a survey, researchers use questionnaires or interviews to obtain specific information about subjects' behavior. These types of studies allow researchers to describe patterns of behavior and discover links or associations between different variables. But since they're not strictly controlled, they cannot imply causation. So simply because two variables correlate with one another does not mean that one variable caused the change in the other. For some interesting and sometimes funny examples of unrelated correlating variables, you can check out the link on this page. Going into some of the pros and cons of each type of descriptive research studies. As with all types of descriptive research, with naturalistic observation, you are viewing real-world behavior without manipulation, which allows you to access the most realistic and representative behaviors most likely to be produced. Usually, the experimenter can't even inform a person that they're being observed because demand characteristics are possible if they know that someone is watching. Unfortunately, this does make it difficult to study many things, as you really can't guarantee an appropriate situation will come along that will produce the behavior that you want to study. So especially if you want to study things that people rarely do. In these cases, it can require long periods of observation to get a single measure of a desired behavior. And even if you do see the behavior of interest, it's really difficult to determine the exact cause of said behavior. A great example of naturalistic observation is the work that Jane Goodall did in observing chimpanzees in the wild. Participant observation allows researchers to interact and participate with populations that they want to learn from. This then allows for different research insights to be gathered from the participant's perspective, providing truly valuable insight. Unfortunately, this type of research can be subject to biases or interpretation from the perspective of the researcher, and the observations may not be repeatable due to the unique contributions of all members. Case studies are extremely detailed reports of a single person, group, or situation that allows researchers to collect a lot of detail. However, they also come with some issues, such as difficulty in determining any cause-effect relationships that might exist, the generalizability of any findings to the general population, or even others in a similar situation is questionable, and of course, researcher bias as well. In a case study, you're only looking at one person, but gathering a lot of data about him, her, or them. So in a famous example, Henry Molaison, better known in the literature as HM, suffered from epileptic seizures leading to his doctors removing his hippocampus from his medial temporal lobes. He then experienced anterograde amnesia after removal of his hippocampus. So for more information, you can watch the YouTube video detailing his case study at the link below. Lastly, the survey has a lot of positive qualities. They are relatively easy to administer. They're quite effective at gathering a lot of information in a fairly short period of time, usually. They are, however, susceptible to biases on two fronts, both from the researchers who are choosing and designing the questions and the form of administration, as well as from the participants. So perhaps from them not wanting to be entirely truthful or not wanting to put themselves in a bad light. On the other side of things, from descriptive research, is experimental research, in which an experiment is conducted, which is the manipulation of one variable under controlled conditions, such that the resulting changes in another variable can be recorded and be observed. Rather than simple correlations, experiments are designed to detect cause and effect relationships, allowing researchers to test theories through controlled experiments that are hypothesis-driven. Hypotheses are central to experiments and are tentative explanations, or more often predictions about a phenomenon. These are then used to design and craft the experiment, including choosing which variables to include and which population of interest they want to study. A theory, on the other hand, is a set of formal statements that explain how and why certain events or phenomena are related to one another on a much broader scale than a hypothesis, and they tend to involve many more moving pieces that are often highly interconnected. So, what makes a good theory? There are certain characteristics that define a good theory. First, it should be consistent with prior observation. It should be as simple as possible, so conforming to the law of parsimony. It should be specific and measurable, and importantly, it needs to establish causality, therefore requiring experimentation to draw cause and effect relationships rather than simple correlations. Lastly, connected to this, it should also be falsifiable. That is something that we can actually test to see whether the theory is correct. If we remember from the previous definition, a variable is any factor that can change in an experiment. So there are a few important roles that variables can play in an experiment. Independent variable is the variable controlled by the experimenter, whereas the dependent variable is the variable that we measure in an experiment. And then extraneous variables are ones that the researcher isn't interested in, but can affect experimental outcomes if not controlled. So it's very important for the researchers to make note of them and measure them accordingly. And this is a very important step in ruling out potential confounding variables.